wow, we got big shout outs. Say, who wants to shout out to Hannah?
Hey Hannah, I miss you.
Okay, that was that. Amazing. Who wants to shout out to Taylor?
Hi Taylor.
Oh, ZZ, big time you, Taylor. Whoa. Taylor, this is a shout out from Mr. Gentz. We miss you. We can't control ZZ without you here. She's already been a pain in the butt.
Jordan and Lily also miss you, but he keeps talking over us.
Okay, they sometimes cheat their way through Pictionary, so I'm not going to talk about them. All right.
Never.
Person number 4, Piranha. Say hi to Piranha.
Hey, Piranha.
Yeah. Emma, we miss you. We miss you in class as well. And Addie Hims. Addie, there's a party at your house tomorrow. I don't know if you know that. We're all coming over. We're having your mom's bars, and it's going to be amazing. So maybe you'll be there.
I'll bring punch.
Yeah, you won't. So, all right. So we've got this great problem. So this is a problem that just needs to be done once in the context of a business. And once you do this once, you're like, okay, now I know the secret to this construction. The idea is that you get this flat piece of tin, okay? Because anybody know what a gutter looks like up on a house, like rainfall gutters, okay? And they're bent pieces of metal. And the places where they're most likely to leak are the places where they are joined together. So they like to have seamless gutters. Well, how in the world do you carry around seamless gutters? Because some of these gutters are 40 feet in length. Can you take a gutter that's 40 feet in length and carry it around in your truck? No. Excuse me. So what they do is they have a roll. Stop that. They have a roll of tin. Okay? This roll of tin. And they unroll the tin to whatever length that they want. They cut it, and then on site they break and bend it. So that way it's seamless. You see what I'm saying?
Pretty nifty, huh?
Yeah. So when they make this break or this bend, the question is, so they got this piece of tin. It's 24 centimeters wide, okay? And they're going to fold it to create a gutter. The base is 10. So they're going to they'll fold it there and there. So it's going to be like that and that. So they're actually then getting rid of, whoop, that was not planned. So that's 7 and that's 7 and that's 10 for a total of 24. Everybody get the idea of what they're trying to do here? Yeah. And the question is, at what angle should the sides be folded? Like, how far do you tilt them up? Do you tilt them up 90 degrees? Do you tilt them up 60 degrees? Do you tilt them up, what angle do you tilt them to maximize the amount of water that the gutter can hold? All right, good question, right? And some people sometimes get mad at the problem, like, there's no way those guys that go install your gutters are going to go out there and do their calculus before they put it up. Well, of course they're not. Somebody's going to do this problem once for that size, and then it will be done, and everybody can just reference it from there. And then somebody will do it if it's a different size. But the fact is, it only has to be done a few times. But you want to be the gutter place that says, hey, we know that ours holds the maximum water because we've done the math, right? So there you go. You're going to do it. So tell me, what do you see? What do you see? Trapezoid. Awesome. Everybody see trapezoid? Yeah. All right. So we're going to need area of a trapezoid, aren't we? Okay. So area of the trapezoid is, what's area of a trapezoid?
The average of the bases.
Average of the bases times the height. So 1/2 times the height times the sum of the bases. Good. Man, you guys are smart. Imagine how hard this class would be if you weren't smart. Man, tough. So I'm going to draw a little bit bigger picture of that so I can make some really good descriptions here because I'm going to need to really get after it when I use this guy here. So I'm going to make a little bit bigger shape and go like. I'm going to put a top on it even though it doesn't have a top so that we could just understand that dimension there because we have two bases going on. So I have this piece, which is my height, which I don't know. I have the first base. Do we know what the first base is? 10. Hey, that was helpful, right? Like that can be plugged in. So I've got that. I know this side is 7, and I know this side is 7. And we're really, what's that?
Nothing.
Go ahead, say it, because many times you say things that are intelligent, you just don't say them loud enough for us to all hear. Okay, I like the idea of making a square. Excellent. Except it will be more of a rectangle, won't it?
Yep, that's
Okay. So really, as we find this area, we have the area of this middle part. We have the area of that. We have the area of that, don't we? Got those couple things. Okay. So let's go through here and see what we can get. We know that this length here is 10. And we're wondering what angle we should bend it. So we're wondering theta here. But in context of the problem, I'm really concerned about using this angle for the setup. So I'll call it beta. So we'll work on finding beta. Once we find beta, how would we find theta? Yeah, they just add to 90 degrees, right? So once we find beta, we'll be good for theta, won't we? Okay. All right. I don't know about you guys, but this looks really tough. Don't we have like 3 different variables going on? Like 4? We've got base 1, we've got base 2, we've got height, and we've got theta. We've really got 4. Which of those 4, base 1, base 2, h, or theta, which one do you think we want? Well, I'm sorry, theta, we'll say beta. Which one do you think we actually want to use as our variable? You have 4 candidates. You got to choose one. Parent, share, talk. Which one do you think you want? Go, talk.
That's what I was going to say.
Five, 4, 3, 2, 1, done. Which one is it?
beta.
So I think I heard height. And height could be a candidate. It really could. It really could.
I guess.
The fact is that what's going to be the best one for us to use is going to be beta, the angle. And part of the key for us to see, there's 2 reasons why. Number 1, the question is asking what angle should we bend it, right? Okay, and so that, if we can make the area as a function of the angle, that's helpful for us. So that's a little bit of a giveaway. The second one comes from this, and you don't know unless you recognize it. This is something you guys haven't seen for a little while, but I'm going to circle that set right there. What does that make you think of? You got it. Come on.
Cosine?
Cosine. Namely, that the cosine of beta is equal to h over 7. Notice as I recognize that, I can solve for h, can't I? If I multiply both sides by 7, I get 7 cosine of beta is equal to h. So now I've gotten rid of this h. It's simply 7 cosine of beta. Well, that's pretty helpful. Obviously, base 1 is 10. That's not going to be a variable that gets used. Base 2 is going to be 10 plus whatever these 2 things are, right? Well, I'll label that as y. Who can tell me what relates those 3 things together? Doesn't sine relate y, 7, and beta together, the opposite over the hypotenuse? So therefore, I have the sine of beta is equal to y over 7. Or 7 sine of beta is equal to y. Y is equal to 7 sine of beta. And so I know this section over here is also 7 sine of beta. Looks like we have beta represented everywhere, don't we? I can now write a formula for area in terms of beta. I have 1/2 times what?
7 cosine beta.
Good. Times 7 cosine of beta. Times base 1 plus base 2. What is base 1? 10. What is base 2?
10 plus 14.
Good. 10 plus 14 sine of beta. Ooh, there we go. What do you think? Hi.
Why are there 2 tens?
Excellent question. So base 1 is 10.
Yeah.
Base 2 is 10 plus the n's. Okay? So I'm going to do just a little bit of work here. It's really all algebra and a little bit of derivative from here. Area in terms of beta is equal to, I have that 1/2 times 7 cosine of beta times 20 plus the 14 sine of beta. Now, I don't know about anybody else, but the 1/2 is kind of bothering me, right? So let's distribute the 1/2 and the 7 cosine of beta through. And I get area in terms of beta is equal to 7 times 20 times 1/2 will give me 70. 70 cosine of beta plus 7 times 14 times 1/2.
42.
Close.
49.
49. Sine of beta, cosine of beta. You okay with that? So I would like to go ahead and take this, and I would like to do what with it? Take the derivative and y. That's where the maximum minimum happen. I don't know what that shape looks like, and it really doesn't require that I know what it looks like. Fact is, it might have something kind of a shape like that. I just know that the maximum occurs when the derivative is equal to 0. That's the beauty of that process. So the power of the calculus at work. We take the derivative, we set it equal to 0. 0 equals, what is the derivative of 70 cosine of beta? Negative 70 sine of beta. 49 sine of beta, cosine of beta. What do I have to do there? Product rule. What's the derivative of 49 sine of beta? 49 cosine times cosine will be cosine squared. So I get a plus 49 cosine squared of beta. Plus, what's the derivative of cosine? Negative sine. Negative sine times 49 sine will be a negative 49 sine squared of beta. What do you think? What's going on in that brain of yours? Ooh, I like that. She said 1. Sine squared plus cosine squared is 1, but we don't have plus. We got minus. Wouldn't that be nice? Nope, sorry. Come on, you got good thoughts. Factor out a... Sure, you can factor out a sine out of those two. Doesn't necessarily really help me. What else could you factor out?
Factor out negative 49.
Yeah, you could divide out, well, you just divide out a -7, right? If you want to make it smaller, should we divide out the -7? Okay, let's divide out -7. Because 0 divided by -7 is still 0. So we get 0 is equal to, now it's positive 7 sine of beta. I'm sorry, 10. Sorry. 10 sine of beta. And there was a -7, so I guess I'd have a -7 cosine squared of beta. And that would have a +7 sine squared of beta. Now, we're going to go back to what Allie said here. She said sine squared plus cosine squared is 1. And we do want to use that because the fact is that it's not very helpful for us to have both sine and cosine. We just want one or the other. Do you think we want this expression expressed in sine or cosine? We want sine because we have a sine and a sine squared. I want to get rid of cosine squared. What do I insert to get rid of cosine squared?
1 minus sine squared.
1 minus sine squared. Because, as Allie said, sine squared plus cosine squared is 1. Everybody see that? Okay, that is the last of our trigonometry substitution. We are done with our derivative. Now we're just going to be solving an equation. I'll write this out. I have 10 sine of beta minus 7 plus 7 sine squared of beta plus 7 sine squared of beta. So 0 equals 7 plus 7 is 14 sine squared of beta. I have a plus 10 sine of beta, and I have a minus 7 on the end.
Wait, so how did you get the minus 7 plus 7 sine squared?
So I took -7 times 1 to get the -7. I took -7 times negative sine squared to get positive sine squared. Okay. I have a quadratic, don't I? Okay. So who's got their quadratic formula plugged into their calculator? Allie's got it. Instead of solving for x, this is solving for sine of beta. Sine of beta has two values. Sine of beta, sine of beta. Allie, plug 14 and 10 and -7 in that quadratic formula and tell me what you get.
I only got one value. 435.
I
Negative
got
1.1.
Yeah, 0.435 negative 1.
That's also
Got that?
Yeah.
Okay. Lily? All right. What's the biggest and smallest that sine can be? What's the biggest sine can be? 1. What's the smallest it can be? So is sine ever equal to -1.14? That answer is not available to us.
Why is it that it can only be as big as?
Do you remember when we graphed sine and cosine? Remember that the maximum height was 1, the bottom height was -1?
But sometimes wasn't it 3 and 4?
Right, so if it was 3 sine of b is equal to that, that's a different situation. Okay, well, that's not what we have here. Okay, all right, so we got that. Can sine be equal to 0.435? Yeah, so for the only time in all of our calculus class, go ahead and change your calculator from radians into degrees, and then we will change it back. This is the only time we will be in degrees, because we know that our people who are constructing the gutters, they're going to be working in degrees, right? We want to give them an answer in degrees. So I have to sine inverse 0.435. And I get 25.78 degrees. So I go back here. Beta is equal to 25.78 degrees. And as I go back up to my problem, this beta value, whoa, don't do that. This beta value right there is 25.78 degrees. So how would I calculate theta? Subtract from 90. And I get 64.22 degrees. And we can say with confidence that we are the gutter installers that optimize the volume of our gutters. We can have confidence that we did it right. You have a problem very similar to that. I think instead of a 7, 10, and 7, I think it's 10, 10, 10. I think that you get your homework. Okay, it'll set up. But I want you to be able to follow that, work through that. You want to play a game?
Yeah.
Let's go play a game. I need you guys to grab your. Oh, bye, Hannah and Emma and Taylor and Addie. We're playing a game without you. So, Matt.